An electronic circuit is composed of individual electronic components, such as resistors, transistors, capacitors, inductors and diodes, connected by conductive wires or traces through which electric current can flow. To be referred to as electronic, rather than electrical, generally at least one active component must be present. The combination of components and wires allows various simple and complex operations to be performed. Signals can be amplified, computations can be performed, and data can be moved from one place to another. 1. Circuits can be constructed of discrete components connected by individual pieces of wire, but today it is much more common to create interconnections by photolithographic techniques on a laminated substrate, a printed circuit board or PCB, and solder the components to these interconnections to create a finished circuit. In an integrated circuit or IC, the components and interconnections are formed on the same substrate, typically a semiconductor such as silicon or, less commonly, gallium arsenide. 2. An electronic circuit can usually be categorized as an analog circuit, a digital circuit, or a mixed signal circuit, a combination of analog circuits and digital circuits. Breadboards, perf boards, and strip boards are common for testing new designs. They allow the designer to make quick changes to the circuit during development. Analog electronic circuits are those in which current or voltage may vary continuously with time to correspond to the information being represented. Analog circuitry is constructed from two fundamental building blocks: series and parallel circuits. In a series circuit, the same current passes through a series of components. A string of Christmas lights is a good example of a series circuit. If one goes out, they all do. In a parallel circuit, all the components are connected to the same voltage, and the current divides between the various components according to their resistance. A simple schematic showing wires, a resistor, and a battery. The basic components of analog circuits are wires, resistors, capacitors, inductors, diodes, and transistors. In 2012, it was demonstrated that memristors can be added to the list of available components. Analog circuits are very commonly represented in schematic diagrams, in which wires are shown as lines, and each component has a unique symbol. Analog circuit analysis employs Kirchhoff's circuit laws. All the currents at a node A place where wires meet, and the voltage around a closed loop of wires is zero. Wires are usually treated as ideal zero voltage interconnections. Any resistance or reactance is captured by explicitly adding a parasitic element, such as a discrete resistor or inductor. Active components such as transistors are often treated as controlled current or voltage sources. For example, a field effect transistor can be modeled as a current source from the source to the drain, with the current controlled by the gate source voltage. An alternative model is to take independent power sources and induction as basic electronic units. This allows modeling frequency dependent. In digital electronic circuits, electric signals take on discrete values to represent logical and numeric values. 3. These values represent the information that is being processed. In the vast majority of cases, binary encoding is used. One voltage, typically the more positive value, represents a binary 1, and another voltage, usually a value near the ground potential 0V, represents a binary 0. Digital circuits make extensive use of transistors, interconnected to create logic gates that provide the functions of Boolean logic, and NAND, or NOR, SOR, and all possible combinations thereof. Transistors interconnected so as to provide positive feedback are used as latches and flip-flops. Circuits that have two or more metastable states, and remain in one of these states until changed by an external input. Digital circuits, therefore, can provide both logic and memory, enabling them to perform arbitrary computational functions. Memory based on flip-flops is known as static random access memory, SRAM. Memory based on the storage of charge in a capacitor, dynamic random access memory, DRAM, is also widely used. The design process for digital circuits is fundamentally different from the process for analog circuits. Each logic gate regenerates the binary signal, so the designer need not